And then to actually reference these things in code, you have to check generate C# file because that's not on by default either. Since finding out this new field of Marble Arena that I wasn't aware of previously via a YouTube commenter on my old videos, and having this whole video on it, this whole new video on this game, it made me wonder, maybe it might be helpful to have something similar to the game's modeling engine, or the Cube 2 engine, which you could use for like a prototyping situation for level design, within like a game engine or something. So I guess I'll just cut to the chase from the beginning. So what I have here is a Cubemap script that generates a model mesh around an array of point vectors comprised of whole numbers. So they're basically just confined to this sort of grid. I also have this relatively simple camera script where I can look around and sort of fly around the world. So what this script is doing is it's generating a starting point if nothing already exists, and generates a cube around each point. So if I click on this, you can see it adds another point in the direction of the side which I clicked on. And then if I scroll up and down, you can see I can keep adding in that direction, or go back and remove things. In fact, if I show what happens with this point list, if I keep adding through this stuff that already exists, you can see I can get through it, and it doesn't add anything until I actually get through it. Because I'm using contains check to see whether I need to add, or if it already exists. Because once it regenerates the geometry, you don't want it to generate overlapping cubes around the same point multiple times. So one lead that I had was this video on mesh generation that Brackeys did. Like, here's how you generate vertices and triangles to create a model. And it did seem like these principles could apply to this. So first off, I wanted to just try and generate a simple cube. I found the thought process behind this pretty interesting. And indeed, it worked. That is, after I figured out that you have to put equals new list after the variable, and then specifically put parentheses after it, in order to use certain functions like add functions. But then it did work. It actually did generate a cube. Although I did get some issues, like it was black at first and then the normals were smoothed out, making it look sort of strangely smooth, especially on a cube, instead of actually looking flat like it's supposed to. So it turns out the mesh functions in code don't have any shading option. You have to construct the entire thing differently. So that means generate 24 vertices, 4 for each side, and connect every 4 into 2 triangles for each side, instead of adding 8 and generating from that. So in the code, triangles are constructed using integer arrays. Every 3 numbers makes up one triangle, and the numbers mean which vertices in the mesh constructing it. Seeing as how tries are actually drawn, it's imperative to make sure the vertex order is running clockwise from where you want to view it, to avoid it being visible from the other side but not that one, because it only draws one side for efficiency reasons. To generate a single mesh comprising all of these cubes, you have to offset the numbers in the triangle array by what point you're currently generating around, times the number of vertices for each cube. I also have this raycast function that basically casts a ray from the camera position, and then checks if what it hit was the object the script is on, and if so, adds a point to the array. Now of course this kind of stuff has been done numerous times, so I want to try and make this work more like Cube 2 engine, instead of just barely Minecraft, so oriented towards more freeform creativity. So I also tried using some vector math to accommodate for any position and scale changes, but I can't figure out rotation. Unity does have inverse transform functions, but I have found they don't really work how I expect them to, at least in terms of rotation, and I don't really know what to use to get that to work. Once I tried to use the default mouse movement for the camera script, I got some sort of warning that it wasn't set up. So I checked the project settings in the input section, and it recommends the new input system that you get through Package Manager. So I'm like, what the heck, I guess I'll try that. I mean, it will become standard one of these days, right? Well, it turns out to be kind of a pain to use. First you have to create a new input actions profile, open that, you have to create a new action map, and there's no like defaults already set up that you can just use, even though strangely the old input system actually already had them and you can just use them. Then there's like 10 things you have to make sure of just to get the type of values correct. You have to save it, you can check autosave, but that's not on by default. And then to actually reference these things in code, you have to check generate C# file because that's not on by default either. I think it is cool. I do like the idea that you can easily set up different maps for gamepads and other devices, and the ability to use delegates, which is like a better, more performant way of setting things up, and not having to use strings, meaning you don't have to type out the exact name every time and make sure you get it right. Although on that note, you do have to use a read value function in your script where you have to guess what type it is. Like, is it a vector? Is it a float? That's kind of not much better. And I don't know if I'm being a moron, but it took me forever just to be able to use mouse velocity for the look function and have it work like it should. I was able to move on, but it does remain annoying to use. So I also have this scroll function that first does the contains check, and then adds or removes the last edit point offset by the edit direction. Next, I wanted to get back to that smoothing normal issue. So instead of using this code, I tried to rewrite the index to something more like this. Instead of sharing 8 verts between tries, I wrote 4 for each side, and structured 2 tries from each 4. Now it does seem to work, except I'm getting this kind of strange effect where it gradually builds in the cubes if you try and scroll. That's not making these shapes look any good, of course, so why is this? Well, it turns out because I was still offsetting the index used for the triangle array by 8, even though I'm now adding 24 vertices. So as a result, the triangles lag behind the vertices. Luckily, that turns out to be very easily fixable, especially relative to everything else. Just changing that one number from 8 to 24, you can see it tightened up these graphics significantly. Well, that's about where I'll break off this story for now. There's obviously a lot of room for improvements, like area selection, adding the ability to work with different grid sizes, merging neighboring coplanar faces, sloping, but this is getting pretty complex already. One thing it should be doing is to eliminate the excess faces in between points that you can't see. To do that though, you have to check if something already exists at each point's 6 neighboring vector values. The default contains check for a list will just do a full loop through it. So if I use that for this, it would have to loop through all points in the list 6 times for each point in the list. So the amount of comparisons it would have to do, you're looking at count by 6. Which you can imagine would exponentially slow it down as the count increases. So ideally you would find some way of sorting them and searching for the right element. However, I wasn't really sure how I wanted to do this for 3-dimensional vectors. Alas though, for being something I just decided on trying out, just on a whim, frankly fully expecting it to not be able to get past the 1 cube, if that, I feel like that's kind of impressive. Well, I hope you found that interesting, and if so, you can let the algorithm know. And that wraps up this part of whatever this is, so thanks for watching.